So this is lesson 89 for Algebra 1. It's due Monday the 6th, and it is just looking at quadratic functions, at different things about quadratic functions. So I'm going to just go through the examples in the book. You're probably going to want your book open to page 585. And just going through some things. This is example 1. This is finding, you want to give the coordinates of each parabola's vertex, then give the minimum or maximum value and the domain and range of the function. Okay, so on A, that first one on A, so the first thing we want to do is identify the vertex. The vertex is either the topmost, because when you're talking about quadratic functions, they graph what's called a parabola. So when you see the graph of a quadratic function, it graphs a parabola. So you can either have an upside down parabola, which looks like an upside down U, or you can have a right side up parabola. This one has a maximum and this one has a minimum. And it's the vertex. Like your vertex is up here on this one with the maximum, your vertex is down here on the minimum. So you're looking for the topmost point or the bottommost point to find your vertex, okay? So on A, the vertex, well, you just look at that bottommost point in the book, and it looks like it's down at 0, -4. So that's your vertex. Then you're asked to give a maximum or a minimum. Well, because this one opens up, that means it has a minimum. It has a minimum, and that minimum is y equals -4. It's the y coordinate of your vertex. That's what the minimum is for this, okay? Then you're asked to find the domain and range. The domain for any parabola at all, any parabola that we work with, is all reals. And since you're going to have to write that a whole lot, you can do a double-sided R for all reals instead of writing all reals. Your range comes from whether it opens up or down, and the minimum or the maximum. So if it opens up, that means all your y. Remember, domain are the x's. Domain stands for your x values, and your x values can be anything in this. Range are your y values, so we want to know what y can be. So when we look at this and there's a minimum and it's opening up, that means y is greater than or equal to whatever the minimum is, which here it's -4. So that's the way you find your vertex, your maximum or minimum, the domain, and range. Okay, so then on B, on example 1, we want the vertex, which B opens down. So that means my vertex is up here. So I find that topmost point, and then you have to watch the scale. It looks like it's right 2 up 5. So there's my vertex. So I'm going to put a V by it because that's the vertex. Then because this opens down, it has a maximum because we're asked if it has a maximum or a minimum. So it opens down, it's a maximum. And that maximum is y equals 5. Then my domain, all reals, because that's what it is. For every single parabola, it's always all reals. Your range, because it's opening down and it has a maximum, that means y is less than or equal to that maximum because 5 is a maximum. So if you have a maximum, that means your range is less than that maximum, okay? So that's finding the vertex, the maximum or minimum, and the domain and range. Okay, then if you look on the next page at example 2, you are finding the zeros of the graph. The zeros of the graph are the x-intercepts. So it's wherever the graph crosses the x-axis. Those are your zeros. The zeros are the x-intercepts. So you just look at the graph. So if we look at A on example 2, it looks like it crosses at, and again, if we watch our scale, it looks like it crosses at -1 and 3. So those are our zeros. That's all you do. It's -1 and 3. You don't have to plug anything in. I don't want you to plug anything in and check them. I want you to know that those are the zeros of the graphs because you just look at the graph and see them, okay? Then on B, there's just 1 because it just touches the x-axis and it touches it at -2. So B is -2. That's the 0. And again, the book shows plugging in on all that kind of stuff. I don't want you to do that. I want you to be able to look at it and go, my zeros are -1 and 3 because those are my x-intercepts. On B, it touches the x-axis at -2, so that's my 1, 0. On C, it doesn't touch the x-axis at all, okay? So like on A, it looks something like this. On B, it touched at -2. On C, it doesn't touch at all. So there's no x-intercepts. There's none. There's no x-intercepts, there's no zeros because it doesn't cross or touch the x-axis. Okay, so that's how you get x-intercepts from a graph. You just look at it, how you get zeros from the graph. You just look at the x-intercepts. You look at where it crosses the x-axis, okay? Then there's something called an axis of symmetry. And it is a vertical line that cuts the parabola into two symmetric parts. Or into symmetric halves, okay? So when you're looking at a parabola, you've got an axis of symmetry that actually goes through the vertex. That's your axis of symmetry. It cuts it into two congruent halves. So there's several different ways to find your axis of symmetry. One way to find the axis of symmetry, which I'm going to put AOS, is that it is the x of the vertex. So if you find the vertex, your axis of symmetry is just the x of your vertex. And you'd have to put like x equals something because it's a line, it's a vertical line, so you've got to put a linear equation. You have to put x equals. So that's one way to do it. So if we look at example 3 on A, the vertex they've got written there is -4.50. It's actually written in the book. They give you that in the book. So they give you the vertex. This is your vertex. So your axis of symmetry would be x equals -4.5. It would be the x coordinate of your vertex. -4.5 is the x coordinate of the vertex, so the axis of symmetry is x equals -4.5. You've got to put the x equals because it's linear, okay? Now, on B, they don't give you the vertex on B. On B, they actually give you x-intercepts. They give you -3, 0 and 5, 0. So what you would do on this to find your axis of symmetry is you would average the x-intercepts. You would take an average of the x-intercepts. So if you wanted the axis of symmetry and you're not given the vertex, you're given the x-intercepts, you just average them. That means you do -3 plus 5 divided by 2. So that would be 2 over 2, which would be 1. So x equals 1 would be your axis of symmetry. Okay, now let me do an additional one like that right quick. So let's say we've got a vertex of 3, -1. That's my vertex. So my axis of symmetry, x equals 3, because it's the x coordinate of your vertex. Okay, then if we're given x-intercepts again, say -5, 0, and 9, 0. Those are my x-intercepts. If I want the axis of symmetry, I average them. -5 plus 9 divided by 2. That'd be 4 divided by 2, so that'd be 2. So x equals 2 is your axis of symmetry. Okay, so that's just showing you if you've got your vertex, it's the x coordinate of your vertex. If you got your x-intercepts, you average them. Which is adding them up and dividing by 2 to find your axis of symmetry. Again, x equals 3, x equals 2, x equals 1, x equals -4.5 because it's a line, it's a vertical line, and you've got to write it as a linear equation, okay? Then there's a third way to find the axis of symmetry. So we can find it if we've got the vertex. We can find it if we've got the x-intercepts. We can also find it by using the little formula -b over 2a. Gives you the axis of symmetry. Now you're going to use this when you see something like y equals x squared plus 6x plus 5. -b over 2a, x squared plus 6x plus 5. So A, B, C. It's your quadratic formula. A is always the coefficient of x squared, B is always the coefficient of x, and C is always your constant. So if we wanted the axis of symmetry here, we would do -6 over 2 times 1. Because B is 6, and then 2 times 1. So we just plug it into that little formula. So that'd be -6 over 2, which would be -3. So x equals -3 is your axis of symmetry. That's your AOS. Okay? So let's try another one like that. Y equals -2x squared plus 3x minus 1. Y equals -2x squared plus 3x minus 1. So A, B, C. A is always your coefficient of x squared. B is always your coefficient of x. And C is your constant. So if I want to find the axis of symmetry, that's x equals -b over 2a. So -3 over 2 times -2, because B is 3, and the formula says to put, negative, opposite that, and then 2 times -2. So I'd have -3 over -4. Some of you are still leaving a negative over a negative as a negative, or just leaving it that way, which you can't. It would be 3 over 4, and it'd be x equals 3 over 4. That's your axis of symmetry. Okay, so let's try another one. Let's see. Y equals -x squared minus 4x plus 3. Y equals -x squared minus 4x plus 3. Again, I want my axis of symmetry, so I'm going to use -b over 2a. A is in front of x squared, or the coefficient of x squared. B is the coefficient of x, and C is 3, and there's a negative in front of that x squared. So it would be -4, because B is negative, so I'd wind up with 2 negatives right there, 2 times -1. So 4 over -2, which is -2. So x equals -2 is your axis of symmetry. Okay. One last one, finding your axis of symmetry like this. Y equals 3x squared plus 5. So this is A. Notice there's no B. I'm going to do -b over 2a, but there's no B. So my B is 0, and C is 5. So I would have -0 over 2 times 3, which would be 0 over 6, which is just 0. So x equals 0 is your axis of symmetry on that one. Okay, then one last thing on the notes. Is example 5 on page 588. Yeah, example 5 on page 588, where you've got a golf ball. It's hit from an elevated platform 10 feet above the ground. It starts with a vertical speed of 160 feet per second. Ignoring friction, the equation y equals -16t squared plus 160t plus 10 gives the height y as a function of time, and we want to find the highest point it reaches and how long it takes to reach it. So what we want to find, if we want the highest point it takes to reach it, notice this is negative, so this parabola would open down because that's a negative. We talked about that before. If it's a negative x squared or t squared, if this quadratic term, the squared term, is negative, then it opens down. We want this highest point and the time it takes to reach it. So we want the vertex. So to find the vertex, you start by finding your axis of symmetry. You start by finding that -b over 2a, that x equals -b over 2a. So A, B, C. So B is 160, so -160 over 2 times -16. So that would be -160 over -32. So then 160 divided by 32, really, because negative and negative goes away. So it's 5. So it's going to take 5 seconds to get to its highest point. Okay? Now we want to find what that maximum height is. So to find that maximum height, we plug the time back into the original equation. So we take that negative 16t squared plus 160t plus 10, and we plug it in. Negative 16, 5 squared, plus 160 times 5, plus 10. And then you just type that in your calculator, just like it is. I'll show you. You can type it in just like it is. So negative 16, 5 squared, plus 160 times 5, plus 10. And you get 410 feet. So that's the highest point it reaches, and it takes 5 seconds to get there. Now you have to find the 5 seconds first, because you have to do the negative b over 2a first, but that's how you do that. Okay, so let's do another one like that. We've got y equals negative 16t squared plus 45t plus 75. Negative 16t squared plus 45t plus 75. So again, I want the highest point, because it opens down again, because that's a negative. So I want the highest point and the time it takes to get there. Time to get to that highest point. So highest point and the time it takes to get there. So I start with negative b over 2a. That's going to find my time right there. And I know that says t, I'm writing x. Guys, it's the same thing. You're finding t, which is the x. You're finding the time. A is negative 16, B is 45, and C is 75. So I'd have negative 45 over 2 times negative 16. So that would be 45 over 32, because it's a negative 45 over negative 32. So then 45 divided by 32, go ahead and give a decimal. So it's about, what do we want to round it to? We'll do 1.4. We'll say it's 1.4 seconds. So it's going to take 1.4 seconds to get to that highest point. 1.4 seconds to get to that highest point. Then we want that highest point. So to find the highest point, you plug in to the original equation. Plus 45 times 1.4 plus 75. So I just plug it into the original equation again. Grab your calculator and plug that in just like it is. So on your calculator it would look like this. Then hit enter. And so it's around 107 feet. If the problem tells you to round to something specifically, then make sure you do it. But that's how you work those, okay? And this is how you're going to work practice J, just like these two examples. Just like these two examples. Follow exactly what I did. Write it down real specifically in your notes and then follow it exactly. You're just plugging in different numbers, okay? So that's what practice J is going to look like. So let me go ahead and give you the assignment. You're going to do the warm-up, which is on page 585. Let's see. Remember for number 2 and number 3 on the warm-up that if it's y equals, positive x squared, if the x squared is positive, it opens up. If that x squared is negative, it opens down. So that should help you on 2 and 3 on the warm-up. Then on number 5 on the warm-up, your choices are y equals 2x, y equals 2x squared, b equals y, b is y equals negative 2x, and d is y equals negative 2x squared. So, and the graph looks like this. The graph is a parabola. Well, A and B are both lines. Those graph lines. And this is opening up. So if it opens up, you need the one of these that would open up. Remember over here, I said if it's a positive x squared, it opens up. So that should help you choose between C and D, which one it is, that would open up. Okay, so that helps you on your warm-up. Then you're going to do practice A through J. Just talked about one that you're going to follow on J. The rest of them, like you can go problem by problem on your notes to be able to do these. I do want to go ahead and talk about A because it's hard to tell on these where the vertex is. The vertex is actually at -1, -4. It opens down. Since it opens down, that means it has a maximum at y equals -4. The domain for all parabolas is all reals. Your range would be y less than or equal to -4 because it opens down. And again, I wanted to do this one, and I'm going to do B as well because what they've done on the scales, it's very hard to tell. Very hard to tell. Then on B, the vertex is 5, -3. It opens up, so it has a minimum at y equals -3. That's where the minimum is. Then your domain is all reals. And your range, because it opens up, it's y greater than or equal to -3. That's your range, okay? Then on C, D, and E, you're looking for x-intercepts. They're very obvious, so just pick those x-intercepts out and write them down. E doesn't even cross, so, and again, I did one just like C, just like D, just like E on the notes. On F, you need to average those x-intercepts to find your axis of symmetry. On G, you need to average the x-intercepts. So F and G both, you've got to average the x-intercepts like I showed you. I showed you 2 of them where you average the x-intercepts to get your axis of symmetry. And remember on F and G have to have x equal to answers. X equal a number because it's the axis of symmetry. H and I are where you're using the -b/2a. Like I showed you several of those. I showed you 4 of those. How to do H and I, where you use the -b/2a. And then I talked about J, and I told you which ones you need to work like J. Okay, then on the homework, a couple of things on the homework. That I want to talk about. One, like number 1, -2 times r plus 2 equals -30. So the first thing you need to do is divide by -2. So you'd have absolute value of r plus 2 equals 15. Then you set up 2 equations. R plus 2 equals 15. R plus 2 equals -15. And you solve those 2 equations. So you can finish those now. You can finish those on your own now. Make sure you finish them. Number 2, 3 times r plus 6 equals 15. So you divide by 3. So absolute value of r plus 6 equals 5. And then set up 2 different equations. R plus 6 equals 5. R plus 6 equals -5. And then you can finish those from there. Okay, so you can finish those 2. But I wanted to get you to that part. Oh, and I need to tell you, you're doing 1 through 15. So you're doing the warm-up. You're doing practice A through J. And then you're doing 1 through 15. But you're going to skip number 12. And I just did 1 and 2 for you. This is due Monday the 6th. I also want to talk about 4, 5, and 6 because some of you are getting confused on this factoring. So I want to go over 4, 5, and 6. This is the perfect square trinomial factoring versus the difference of 2 squares, okay? So I just want to go over it again so you've got it again. So for it to be a perfect square trinomial, it's got to have 3 terms, which this does. And then the first one has to have a square root, and the last one has to have a square root. And that last sign must be a positive. If it's not a perfect square trinomial. So square root of 100y squared is 10y. Square root of 16 is 4. Find the product, 40y. When you find that product, if you double it and can get 80, you're good. Well, we can. 40 times 2 is 80. So that's going to factor into 10y, that square root, minus, because I need that sign, 4, that square root, all squared. It factors into a binomial squared. This is a perfect square trinomial. Well, this is the perfect square trinomial. This is a binomial squared, and that's what it factors into. So hopefully that'll help get the dust off your brain on perfect square trinomials. Then on number 5, 81x squared minus 1, this is the difference of 2 squares. Because there's 2 of them, there's a difference, and they both have a square root, 9x and 1. So you do 9x minus 1 and 9x plus 1. And that's how it factors every time. That's the difference of 2 squares. And that's how it factors. every time. So hopefully that helps on the difference of two squares. Then number 6, we've got 9x squared minus 42c plus 49. 9x squared minus 42c plus 49. Got a square root, got a square root. So 3x and 7. 3x and 7 is 21. C, hold on. Is it C or X? Oh, guys, sorry, it's C. C. If I double that, I get 42. 2 times 21 is 42. So 3c minus 7, all squared. Perfect square trinomial. That's how you factor perfect square trinomials and difference of two squares. So hopefully that'll help, you know, get the dust off your brains, that kind of thing. 7 is just distance formula. 8 and 9 are like less than 88, so go back and look at those. 10 and 11 are finding the axis of symmetry using negative b over 2a. Use that little formula, negative b over 2a for 10 and 11. Then I also want to show you 13 to just kind of get the dust off your brains on certain things. 13, you are driving on a highway that has a speed limit of 65 miles per hour and a minimum speed limit of 45. Write a compound inequality. So the way I want you to write this compound inequality is as a compound inequality. Don't use and. The speed has to be between 45 and 65, so that's the way it should be written, and they should be less than signs. So make sure that you write number 13 like that. Then on number 14, again, you've got this graph. That's 5, that's 1. So it's between. And you don't need an equal to bar on the 1 because you don't have a closed circle. So that's the way 14 should be written. Do not use and. Do not use and. Don't use and on those. I don't want you to. Okay, then on 15, you have this trapezoid that has a height of 2. It has a square of 49 plus 4 here, and a square root of 36 plus 8 up here. Now, you want to find the area. So area of a trapezoid is B1 plus B2 times the height divided by 2. Well, this is B2, this is B1. It really doesn't matter. You've got two bases, okay? So you're going to add your bases. You're going to multiply by 2 because that's your height, and you're going to divide by 2. Well, don't freak out at these bases. What is the square root of 49? 7. So this side is just 11. Square root of 36, 6. 6 plus 8 is 14. So this base is 14. So you're doing 14 plus 11, getting that added up, multiplying by 2, and then dividing by 2 to find the area. And you're going to put meters squared. So you can finish 15 now. Okay, and again, this is due Monday the 6th. Due Monday the 6th. Okay.